here we go. Oh, what's this? Yeah, okay.
Open.
Open? Yes, I'll open this. Don't mind if I do. What is in this ginormous box? What could it possibly be? Dax, I'll give you a hint. It starts with 3D and it ends with printer. It's funny that whenever you want help, you say mama. Why don't you say dada when you want help?
Dada.
There you go. Okay, what can I do for you? You want to zip it back up? Okay, I'll hold it. I'll start it. Ready? Now you can finish it. Go ahead and pull that. Oh, look at that. It's a cheap zipper and it already broke. Good thing we don't really need this little case. Let's see if Dada can fix it. Nope, not so much. There we go. Now it's all fixed. That's open. That's closed. There we go.
Dada.
Yo, what's up?
Me.
Okay, we're going to build a printer now.
Me.
What do you think? It's pretty easy. It's just 2 pieces to put together. But we need this. You can't throw that away. We need this to put the printer together. Yeah. Okay, can I move you here?
No.
Let's move you to right there. Don't fall off the table. The end of the table's behind you. So that needs to get mounted right there like so. That's ready to go. Now Dada needs the bolts and the tool. What do you think? You think there's a bolt in the... Can you dump all that on the table? There we go. Okay, what do we got here? So there it is. It looks like I just got to put about 4 bolts in and it will be fully assembled. Connect these wires. It's hardly a kit. It's more of a flat packed but fully assembled deal. So pretty nice. And it looks like it's going to be the highest quality printer that I've seen coming from China. Really, all the details are there. So I'm going to cut the film here and we'll get back to this printer once I've got it fully running and we'll talk about it. What do you think of your new printer, Dax? Do you like this thing? Mm-hmm. Yeah? Is it well made? Yeah, I think so too. And the whole thing is set up, you guys. That was the easiest printer I've ever had to assemble. There was 8 screws. 2 screws here and 2 screws there that hold the vertical posts to the lower assembly. And then up here, there was 4 screws. 1, 2, 3, 4 screws there to hold the filament spool holder. Now, these types of spool holders get a lot of grief from people, but I think that that's unearned because I'm loving this. Now, this is my first experience with this type of spool holder. I don't review a whole lot of printers, so this is the first time. But look at how smoothly this unrolls. It's just a nice, consistent motion, which is pretty friction-free. Like that doesn't take a whole lot of effort. So that means you're not gonna get any jams down here in the nozzle, which are caused by difficulty of unwinding the filament up here. So this particular roll of PLA filament came with these inserts here, which are meant to snap inside there and make it easier to roll on one of these bars. And that's actually a pretty tight fit to where it's not going to roll. And even if you had a smaller diameter of the axle here, it still has problems. So typically, I lose these things. They just pop off too easily, and so I don't trust them to stay on for the entirety of a long print. If I'm gonna walk away, this is just another failure point that could cause a jam. So yeah, so basically I take these things off and throw them away as soon as I get the roll. Well, a lot of the rolls that I've been getting lately are like this, where they don't have a lip on the inside. So this is meant to be the lip. And that means that I have a large bit of surface area that engages with the axle. So you can see the axle sitting on it. Not only that, there's these imperfections in there that tend to sort of bind up on the axle. So let me show you what I'm talking about. Here I'm gonna give a nice consistent slow pull of the tail of the filament here and watch the motion of the spool on the you see that? I'm not jerking it. It's just rolling around like that and getting caught. So you do not get a smooth roll off the roll with this axle type system. And this is very common. You see this on Creality printers and many other printers from China. But at any rate, I think this solution is superior. Having seen this one in the flesh for the first time. And since we're talking about the filament feeding, check out this filament run out detector. Now inside of this casing here is just a clicky, like an end stop switch, and check out how easy that is to load. So unlike all the other switches that I've tested of this type coming from China that kind of jam as you're trying to load them, this one has a nice smooth path through there. So I don't even need to replace that with the optical sensor like I was thinking I was going to do. This one is going to function just fine. So down here we see a geared extruder. So I really am happy with that extruder motor there. And it's a direct drive, so you can print flexible filaments and you should have no issues on this printer. So far, everything I'm seeing on this printer is just really top-notch, high quality. So probably a 3-to-1 gear ratio on that extruder. I love the centripetal, I don't know which word to use there, but I love that fan, the blower fan. I do not love the single point of exit for the air coming off the fan. I'd love to see a split cooling fan there, so I think that's going to be the only change that I'm going to make to this printer. Now down here on the control board, we can actually go into more, and we can choose the color on the hot end there. So we got an RGB LED, whichever color you want to be illuminating your print, or you can just turn it off. So interesting little feature that I've never seen before. Let's just go with the white light. And yeah, like I said, quality everywhere. So this is a 110 volt AC bed. I do not want to bake that sticker onto the bed though, so I'm going to remove that. And looking at this bed, speaking of which, it's that, what is it? I can't remember the name of the company that originally started making this style of bed, but basically it's the glass with the etching in it. You can see it kind of right there on the edges. So it is a glass bed, but it's got that sort of texture to it to help prints stick better. Anyway, under the bed, we see this really great insulation. So yeah, so that bed is going to get up to temperature very quickly. Pretty great, you guys. Quality everywhere. The highest quality thing, though, has to be these ribbon cables. So ribbon cables are going to behave a bit like a cable chain. However, for the bed, there's, of course, no ribbon cable. You need that large bit of wiring to get the amount of current that you need to heat up that large bed. Now, that is a 300 millimeter by 300 millimeter bed, so it's a pretty decent size. And look at the end stops are all this fancy type of inductive sensor. So I love these things. So that's Y, that's Z, and let's see if we can find the one for the X. There it is, right there. Listen to how quiet this machine is. God, that sounds good. Like, they used really high quality stepper motors, high quality stepper drivers, and then they've got these blue plastic sound absorbing mounts for the lead screw nut. So on both sides. And speaking of both sides, there are these two stepper motors back here to control travel in the Z direction. And you know, these things are going to be tied together in the wiring loom to the control board, which means that they're going to act in tandem to lift and lower the Z bar here, the gantry that the X carriage rides are on. So you're always going to have a really good travel like that. But the problem with this type of a system, which we see in a lot of other printers, is that when the printer is turned off, one or the other stepper motor can get spun while that one stays static and doesn't move. And that causes the whole gantry to sort of twist or cant to one side or the other, which means that the next time you come to print, your bed is all out of alignment, and that's no good. So in order to fix that problem, what they've done up here is they've tied both of these two together through a belt. So here we have toothed pulleys and that belt loop riding on them, and that keeps them tied together completely. So they're tied together through the wiring harness and into the controller, but also physically tied together with this belt. And that is a redundant system, which, hey, I have not seen a redundant system yet in 3D printing. So good on you guys, the engineers, designers there at Artillery, for putting this into their printer. I'm really impressed. Here I am printing from a thumb drive, and you can see I'm in, about halfway done with this test print, my typical test print. And you guys hear that? Whenever it does a retraction move, it makes an interesting noise. So that's basically the sound it makes when the extruder stepper motor has to move rapidly. other than that, this is probably the quietest printer that I've ever reviewed in its stock form. So really, really nice in that regard. And this is what it looks like printing in the dark. And all you can do while it's in the middle of a print is turn the light either on or off. You don't have the option to change the color while it's in the middle of a print. So let's go over the extra things that come in the box with this printer. In the bag here, we have 2 extra extruder arms. Now, I wasn't aware that these things could get worn out, but I guess they can because they've given us 2 extra ones. We've also got new pulley wheels. So these things obviously go wherever the motion system belongs. So we've got wheels here on the X carriage, the Z carriage, and also under the bed there for the Y travel as well. So that is actually a nice touch. I've been printing for quite a few hours on my Creality printers, and I've never worn out one of these, but you know, and you can also buy replacements for these on the usual Chinese shops, but dang, they kind of thought of everything. So I don't see these wearing out, and I don't see the wheels wearing out, but if they do wear out, you've got extras. And also, if you break a ribbon cable, you've got extra ribbon cables, as well as extra gaffer's tape, like this high quality tape here, to hold down the ribbon cables. They give you this really high quality wrench. This isn't your normal stamped sheet metal wrench. That's for changing your nozzle, which is awesome. Speaking of changing your nozzle, they give you an extra one. This is for the Volcano hotend, I should say the cloned Volcano hotend that comes on the printer. Then, of course, you've got your Allen keys that you will need, a spare LED in case that little LED module burns out, and of course, a couple of extra nuts and bolts from the 6 or 8 that you had to install when you installed the machine. Noticeably absent from this toolkit is a pair of flush cutters similar to this. You find these in almost every single other 3D printer kit, and they're indispensable as far as like cutting your filament to length and also trimming you know, little goobers off your finished prints. So these are incredibly useful, and that kit really should have come with a pair of them in case people don't already have one. So if you don't have a pair of these, you probably should order one if you're going to get this printer. Let's take a look at this test print, shall we? We can see some ghosting present in the sides. So that it was with the Y movement of the bed. And the bed weighs quite a bit, and also the belt tension is, actually it's not bad. So that is a thin belt, and that is a lot of mass that has to start and stop. So you're gonna get some flex in the belt, some stretch in the belt, which is gonna lead to wiggle, and it's the tiniest bit of wiggle, but it manifests there in that rippling that you're seeing on the wall of the print. So in the X direction, we can see no ghosting. It looks really good in that direction, and that's easy to explain. This is a pretty lightweight apparatus, so to be throwing that back and forth, it's not hard to start and stop, and it's got the same size belt here, and it's actually a little bit tighter. So I might be able to remove that ghosting there on the sides by tensioning the belt on the y-axis. But the thing that I can't easily remove, and that is the stringing. You see the goobers there on the sides on the walls, there in the gap in the window? And that is because of the Volcano hotend. You see that Volcano heater block in there? So that is a part designed by E3D and cloned by China. And the whole point of it is to extrude filament more quickly than normal. And you would need to do that when you're printing very quickly, which is something you want to do when you have a larger format printer. So this is a 300 millimeter bed, so you're starting to get into large format with 300 millimeters. And well, throwing that bed back and forth more quickly is going to lead to more ghosting. So a moving bed is a bad idea for a large format printer. So this is the conundrum that they've put us in with this printer. We'd like to slow down the print speed because we don't want the ghosting happening because of the large mass on the bed, but the hotend is designed for a fast print speed with the E3D Volcano. So it's a poor combination. So bad design choices there. And that's just unfortunate because the rest of this printer is just so solid. Like, this is the highest quality machine that I've seen coming out of China, except for that issue. So this is the Volcano nozzle, and you can see how long the melt chamber is. That's the entire length of the nozzle pretty much. So down in there, it's where the filament starts to get molten, and it just sits in there. So trying to pull the filament back on a retraction move means you have to have a suction cup that pulls it quite a bit up from the nozzle. And that just doesn't work as well as when you have the tiny little melt chamber on a standard size nozzle. So that's this one. So the whole point of having a giant melt chamber is you know your filament will get molten when you're extruding extremely quickly. But like I said, that's only needed on printers that can move quickly, and this one can't move that quickly because this bed is too heavy. So what we need to do is put a regular sized heatsink onto this printer. So this would be nice to mount right there. The problem is that we don't have enough clearance. So if I were to use this regular stainless steel heat break and mount it into the plate here for the geared extruder. So if I do this, then what's going to happen is I'm not going to have enough clearance for the nozzle, or the nozzle is going to be recessed up too high into the printer, and we're going to have clearance issues. Meaning the fan shroud is going to hit the bed, so is the pulley wheel here, as well as the anodized aluminum portion. Those are all going to hit the bed before the nozzle's even touching the bed, because the nozzle will be sitting up too high. So how can we get this hardware to work on this machine? This is a very interesting little detail. You see the temperature sensor here. The thermistor is potted into this little ferrule, and that ferrule fits perfectly into the intended hole there on the heater block, and it's a nice tight fit. So you, in theory, should get a really good, accurate temperature reading from that. But the problem is, I don't know what temperature the potting compound is rated to. So you can see I've got the thermistor installed into the regular sized heater block, and the heater cartridge here will also fit just fine into that. So that's solved, and we don't need to do anything more there. Now, what I do need to do is make up the difference in height here between the two heated chambers. So I've put my caliper here on each of these and subtracted one from the other, and I get 8.75 millimeters is the difference there. So I need to add 8.75 millimeters of length to the threads on this heat break. And the way I'm going to do that is I'm just going to cut off 8.75 millimeters off of this heat break that came with the machine, and I'm going to thread that up inside of the hole here. And while I'm at it, I'm also going to cut off 8.75 millimeters off the bottom of this E3D V6 cooling heatsink thing, and that's just going to give me a little bit more cooling on my extra long heat break. And here we have it, the top of the heat break that I cut off with a Dremel tool. And you can see I put a slot in there so that I can get a screwdriver on it if ever I need to get that back out again. And here's my heatsink. This is pretty sketchy. It's held on there by exactly 1 1/4 turns, so just a little bit more than a single thread that's actually biting. And the reason for that, you can see, is this top portion where the threads have been ground off, and that's just so that it can get all the way down into the hole that was not drilled with a bottoming tap. That's why they designed the part like that. But I really could use those threads at this moment because there's just really not that much holding it on there. So this is going to be constantly heating up and cooling down, which is going to be problematic. I really don't think this is going to work for very long. I mean, it'll work for like a print or two, but the only saving grace is the fact that I can use this as sort of a pressure nut to hopefully sort of tighten it down onto that, and you know, just keep it all from moving, just keep it all locked in place. But you know, given the heat expansion and contraction and all the heat cycles this is going to go through, I really don't have that much faith in this apparatus. Okay, so that's all assembled and it's looking good. We're going to have plenty of clearance there. The wheel over here is not going to bump the bed, and neither is the fan shroud. But now what I need to do is go drill and tap new holes right here for the fan assembly. So what we need is for the fan to cool these new fins down below. So we need to mount the fan instead of flush like that. We need it to be down somewhere like that. Well, that is set up and working nicely with one exception. This fan corner now collides with the stepper motor, so it does not reach the X end stop. And this is what I've ended up with. You can see the normally sized heater block right there. There's my stack of cooling fins, and this is a fan shroud that's really sort of containing the air coming from this fan over here and directing it right through those cooling fins. So you can see the fan here, and the entire lower half is basically being directed at those cooling fins, where the upper half is still being directed at this heatsink, which really isn't very consequential any longer. Now that I've got those cooling fins down there, they're doing the bulk of the cooling. But I did use the 2 holes that I drilled and tapped. Oh yeah, I forgot to mention, I fixed the X homing issue. You can see that there's now ample clearance for it to home there. Now there might be an easier way to do the whole thing, and that is the geared extruder, the cooling heatsink, as well as the extruder stepper motor that's behind this covering. That whole thing might be able to be lowered. Let's talk about test prints. So here we have the Volcano hotend. This was the stock hardware setup for the printer, and we talked about this a minute ago. You can see all that stringing there in the window as it's trying to jump between the 2 pillars. The exact same G-code was used to produce this test print, and this one was done with the new updated regular sized heater block, and you can see that the stringing, the goobers on the edges there inside the window have all but been eliminated. Now, there are still some slight artifacts there. I could probably reduce them even further playing with the slicer settings, but I mean, these 2 are the exact same G-code, so that shows you that it's 100% hardware. And unless you're printing at a very high speed, you do not need the Volcano hotend. So the regular size heater block is the way to go. So these are just regular old PLA, and the only thing more to talk about here is to take a look at that little triangle. You see that triangle there at the top? That didn't lay down a first layer. And it's not because it didn't stick to the bed. It's because the printer actually didn't print in that area. And so we'll cover that more here in a second. But let's first talk about these green test prints here. And I made these with a flexible material, and it is a very flexible filament. It is this FlexFill 92A hardness Filamentum filament. So it's basically a TPU in green, and it's the most floppy, flexible filament that I could get my hands on. And in fact, Filamentum, in case you guys don't know, is a great filament manufacturer coming out of the Czech Republic. Go ahead and check out this video I made on my other channel where I used some of their filament to manufacture mirror mounts to go on the outside of my motorhome. Permanent electronically adjustable mirrors mounted with Filamentum filament to my motorhome. Pretty cool stuff. Just to give you guys an idea about this filament, it's basically a rubber band. It's incredible that we can even print with this stuff, because the first thing you learn in engineering school is don't push on a rope. You're supposed to pull ropes, tension members, right? So this first print here looks pretty terrible, and that was done with the new heater block hotend here on the printer, but I had cooling turned off, so there was no part cooling, and that's why the spire looks so terrible and why the ceiling is just really incredibly droopy. But something to notice there on the bottom, you see that, again, like the triangle over here, we're missing some print. It just doesn't print in some areas. So anyway, I turned the part cooling on, and that was the print that I ended up with when I did that. So part cooling did quite a lot of wonders to improve the quality there. You don't see any stringing. Pretty great. You do get a lot of ceiling droop, and that spire is not perfect. You see it gets kind of rough up there near the top. So just to compare to what other printers can do, I printed this one on my Creality Ender 3 with the forked cooling. So it has cooling directed at both sides of the spire as it's printing upwards. And you can see that spire from the Ender 3 is a whole lot cleaner than the spire here with this printer with the single ejection source coming from the fan. So split cooling, cooling from both sides of the nozzle is the way to go. But you see all that stringing right there on my thumb? That's pretty substantial. And this is the exact same G-code being run on this printer and on the Ender 3. So that bit of stringing right there is purely caused by the Bowden tube on the Ender 3. So it is true, direct drive extruders for extremely flexible filament are the way to go. But you know, that's the only use case that I've really found it necessary for a direct drive instead of a Bowden tube. Okay, so now let's talk about the missing lines on that first layer. You'll notice here, exact same G-code file printed on the Ender 3, and it printed all the way through. Here on the artillery Sidewinder, we see that this print is missing that section there. So was this first ugly print missing that section there. And on this other print, we were missing that upper corner. You can see it right up there. See it? So what the heck is going on here? Well, I think it's a buffering issue. So keep in mind that this screen here is its own separate computer module from the board that drives the motion for this printer. And this screen talks to the USB drive, and it's supposed to talk to the SD drive here as well, the micro SD card drive. Now, I have not been able to print with a micro SD card. I've tried 4 different micro SD cards now. I do have some abused micro SD cards. I use them in my sound recorders as well as my cameras for this channel. So I don't know, maybe all of my SD cards are corrupted. Like they work, but I don't know. Anyway, the only way I've been able to get this thing to print is through the USB. And I've tried 2 different USBs. In fact, this was a test with a different USB, and you can see I stopped it after that first layer. You can see what's going on here. So you see that real thick diagonal line going across there? That is the extruder trying to push as much filament as was supposed to be extruded in that whole area. So the X and Y jumped a whole chunk, and the extruder tried to squeeze out a whole bunch of extra filament. So you can just see it. It did it across the diagonal, and then it was still squeezing out a whole bunch of extra right there on that first line. So I really do think this is a buffering issue, which is interesting because I had another printer with a screen that was separate, like a touch screen here that was separate from the module that runs the printer, and it had the same issue, only on that printer it was far worse. Like the whole printer would just sort of freeze and just stand still for a minute until the buffering caught up to it, and then it would continue to run. So at least this is better than the last one, but I'm starting to think that any printer from China that comes with a touch screen is potentially going to have this issue. Now I haven't tested, I've got a sample size of 2, so that's obviously not valid, but any other people with experience, please chime in. Tell me if you're getting skips like this on your printer because of the touchscreen. Look at this, you guys. It's completely frozen. Talk about buffering issues. It says it's printing, but it's completely frozen right there. Okay, let's pause this print. And we can see that that first layer did not lay down here in this upper corner. So it's now laying down the second layer on top of the first layer without printing that corner. So this weird glitching where it even freezes up sometimes seems to be the rule and not the exception. So more often than not, it's doing this glitchy thing. So I'm gonna try slicing this in Cura. Currently these files are sliced with Simplify 3D. So maybe the controller on this printer just doesn't like Simplify 3D files, but let's give it a try. Well, the part sliced in Cura seems to be printing perfectly. So basically this printer does not like to play nice with Simplify 3D. I couldn't leave well enough alone. I had to figure out this other solution. So you can see here there's these 5 holes, there's the 4 mounting holes, and then this big recess. And that's there because you see here on this pancake stepper motor that there's this bumped up portion right here. And so that has to go into the big hole there. So you're gonna have to grind away at that, 8.75 millimeters down, and lower these 4 holes 8.75 millimeters down. Once this is lowered, we'll be able to basically just put a regular sized heater block onto the extruder without having to worry about all this other stuff that I've done. But this solution, moving these holes, will mean that you're going to rely on the stock cooling solution. So the stock cooling solution has this aluminum plate that the heater block and heat break mount into, and then this cooling heatsink here mounts on that face. So this is the back face of the heatsink and the front face of this part here. And there's no thermal paste between these two. Not only that, there's a thickness here and there's a thickness to the back of the cooling the heatsink there. So you're going to have to cool through this thickness, that thickness before you get to the cooling fins. So I don't think that the cooling on this is going to be nearly as good as you find on the E3D Titan Aero. Now this is, like I said, a version of a Titan Aero. Clearly they started with a copy of the Titan Aero and modified it, but it is changed. So it's not a carbon copy. It's not a clone, which is the true evil. Now this is not ideal, definitely sort of a copycat product, but it's okay. It passes muster just because they changed it a bit. So yeah, I think that my solution here with these cooling fins that I added is superior to the stock cooling solution. And the only problem that I have with my design here is the fact that it's held onto this block here with only 1 1/4 threads. Like, that's just not enough bearing thread. And then so it's just not possible to get a throat or a heat break that threads all the way up in there unless I custom make one or get one custom made for me, which would be, I think, an ideal little solution there. Much better than the stock cooling. So in combination, of course, with my cooling fan duct here, which you see, this printed part. So this is much more complicated the way that I've done it versus the very simple way to do it, to just move these holes. Okay, all of the drilling and filing is done, and now you can see I can either mount it in the stock position or in the lower position for use with the smaller heater block. Another quick note about this modification: this is the PTFE liner that comes inside of this metal part here, and if you want to retain the ability to go back to the Volcano hotend for some reason, you're going to need to get some other PTFE tubing because you're going to have to cut this one short. Whoops! So doing this modification is also going to require that you grind away for some clearance for this gear. See how it's hitting? So we're going to need to grind away right in there. Another attention to detail moment to point out on this printer is this. I think this is called a riv nut, and basically it's a steel threaded insert that inserts into an aluminum hole. And they could have just drilled and tapped the aluminum, but aluminum threads are a lot weaker than steel and easy to strip out. So they put riv nuts everywhere on this printer. The printer is just finishing up this test print here with the whole apparatus in the lowered position. You can see the wheel from the extruder is almost rubbing this part of the cooling fan. And also, I removed the cover here from this area because I would have had to cut out more of this part right here in order to get clearance. So here are the test prints that matter. Here's the one from the Volcano hotend, and you can see quite a bit of stringing happening there in the window. Next to it here is the setup that we were just testing, and you can still see some slight bit of stringing here on this edge, and there's also some over here. What you can't quite see in this light, and I don't know if I can get it to show, but there is some wispy threads down in there as well. There we go. You see those wispy threads in there? So keep in mind that this is PLA printed at 240 degrees. I like to get really good layer adhesion, so I printed that very high temperature for PLA. So, you know, I could probably lower the temperature as well as doing some wiping moves and completely eliminate stringing altogether in the slicer. But the point of this test is not to eliminate stringing, it's to show the difference in the hardware performance. So here on the right is the lowest amount of stringing that I was able to get with this G-code file. All three of these, again, same G-code. So, you know, obviously that's the best performance, and that's because there's no heat creep happening with this hardware configuration. So this is superior, and really the only drawback to this setup is that it's held on there with just a single thread into that aluminum, you know, part there. So the final thing to say about the setup where it's lowered is the fact that the light here, it pretty much has to be removed. You're going to have to take that off if you want to run split cooling. Like, there just isn't enough room for a cooling duct to go on that side of the nozzle and also retain that light. So not tragic. I mean, the light was nice to have, but I think split cooling is better. You see the top of that slot there? I was able to file down that slot and the one over here as well to where I could get the split cooling to sit upwards enough. And you can see down here, it just barely clears the nozzle. So the nozzle will be able to print on that bed and without colliding with the split cooling. But we're back to that same old collision problem that we had before. You can see I've trimmed the wire here and also cut away the plastic so that we get good clearance and it can home. And this is the result printing with the new split cooling fan duct from Thingiverse. It looks better than it did before here on the spire. So this was the direct single source of cooling. And if we compare those spires side by side, we can get a little bit of a picture. We can see that higher up the spire, it looks good. It's uninterrupted. It doesn't start to look bad till right about there. So this one starts to look bad down lower. So split cooling is more effective, but it's still not as good as the results from the Ender 3, which looks pretty good all the way up. So my Ender 3 cooling solution is still superior. I guess I'm gonna have to design my own split cooling fan duct for this printer. So that unfortunately takes like 4 hours to do, but we can see that there is definitely improvement to be had redesigning this. So here's the solution that I've come up with. It took way more than 4 hours, especially if you consider print times on the 3 different versions that I had to make to get the fitment and you know, the orientation of everything just right. So yeah, the way it functions is the fan here is canted at 45 degrees, which gets you better airflow because there's less of a direction change for that air coming out of the fan. And the air is splits into these 2 different ducts, which each blast from the opposite sides of the nozzle. So I'm pretty proud of that solution. And I was able to get that symmetrical, you know, air happening because I moved the fan over to the right. So it's centered on the nozzle now. The parts bolt together, so this is the upper assembly and the lower assembly, and you can see that screw underneath there that bolts them together, and that's just so that we can get them to print easily without needing any support material. So yeah, it's a pretty clever solution. I'm pretty proud of it. So let's give it a test run and see how it does making one of these flexible filament test prints. We have the complete and total success right here, which is the new part cooling on this direct drive machine. So look at that, no stringing, no goobers on the sides, and a spire that's every bit as good as what came off of the Ender 3. Oh, and also you can see that I fixed that the issue with the G-code. So we have a perfectly laid down first layer. So I love this printer now, absolutely my go-to printer for printing flexibles, that's for sure. Let's talk about how I fixed that first layer issue where it was skipping, you know, big sections of the first layer. So this is a notepad, and we're looking at the actual text of the G-code generated by Simplify 3D. And like I said, I didn't have the problem with Kira, but I did with Simplify 3D. So Simplify 3D, for some reason, has this massive amount of commenting that happens in the beginning of every file. So all I did was delete that commenting. They're comments anyway, they have nothing to do with the actual code that's running the print. So that's it. Then I just saved this this file, so the G-code is unchanged, and the printer ran just fine after that. So my theory, again, same theory as before, it's a buffering issue. It's just a theory. I'm not, you know, super in depth with this machine, but I think that basically, like, there's a certain number of lines that the screen feeds to the 8-bit controller. And I think that the bulk of those lines in the beginning are taken up by all these stupid comments. And so there's just not enough lines, and it gets to a point somewhere down here where it just runs out of buffer and it doesn't have any movements left to make until it gets the new buffer. Because, you know, like, it wasted a bunch of its buffered lines on stupid comments here at the top. So anyway, Joel, I know that you use Simplify 3D as well, so this is probably the source of the issue that you're having with your weird bed triangles. I had that same behavior happen as well. So I'm betting that this is the same issue for you, so just go ahead and delete those lines, and that's your problem solved. And maybe this means we can be friends now, and you'll give me a shout out in your videos like you do for the other smaller channels. That would be appreciated. Let's talk about this print surface for a second. So I've printed with PLA, PETG, and TPU/TPE, so flexible filament. And especially with the PLA, this print surface is incredible. It sticks at 60 degrees, and as soon as the bed cools down, the parts fall off, like they aren't stuck in the slightest. So there has to be more going on here than just a textured glass bed. And I don't know if you guys can see the slight change in patina that happens right about here and right about there. So I've been printing in this area, and I actually cleaned off that at one point to try to, put some more glue stick down I thought I might need, or just to experiment. And what I did was I cleaned the bed first with a little bit of rubbing alcohol. So let me just show you guys what happens when you do that. So I'll just continue to clean past this line here. It gets kind of sticky, like I can feel the resistance on the bed. And if I look, there's this orange hue to the to what's coming up. So I think that they coated this with something at the factory. So maybe they got some industrial strength hairspray or something like that and just put a nice, even, thin coating across it. So at this point, I'm going to have to get my own hairspray and spray it on there, or my favorite is glue stick, just because it is so easy to apply and then to wipe up. I've been using a flexible spring steel bed with a PEI coating on it, and yeah, it's pretty nice. It's nice to take your big prints and be able to pop them off by just flexing it like an ice cube tray. But with this bed, it wouldn't even be necessary. When it cools down, the part just automatically, detaches from the bed by itself. I would say this is equally usable to the flexible PEI bed. Warranty void if seal is broken. It's the first time I've seen that sticker on a 3D printer from China. So they don't want me to look under the hood, huh? What do you think they're trying to hide? I wonder what craptacular goodness we're gonna find running this machine. Actually, it's not too bad. So these are the lines that go to the bed, and you can see that they are wired in here to the AC portion of the power supply. Speaking of which, it is quite small, but it does not need to be large, because all it's doing is powering the control board and also running the hot end. So that's not a whole lot of draw once you eliminate the bed. And so there is your solid state relay for controlling the bed with AC voltage. And the stepper motor drivers here are pretty good, judging by how quiet the machine runs. So I guess I'm gonna have to pop off one of these heat sinks just to take a look at that. FS31W01, that is definitely not your Polu A4988 crappy stepper motor driver that we usually see on all these boards coming from China. But look at that soldering job down here. They're like pins are soldered together, so the quality isn't there unless they meant to do that. So this control board here is a Hesai, whatever that brand name is. I've never heard of that before. But it's a pretty good board, 2560, so still an 8-bit chip, not a 32-bit chip like you'd find on a Duet board or anything like that. But it does have the detachable stepper motor drivers, which I really like to see. Over here, I don't know about these electronics, but this is just your screen control board, and like I said, this is a standalone computer that feeds G-code line by line to the control board there. And I don't think that the SD card is working. I really don't. I tried 4 different SD cards, one of them which works perfectly in my other printers. So I think that is faulty, but the USB drive does work for loading prints. So all in all, it's a pretty well-built electronics cabinet. We got insulators and crimped connections everywhere. And then of course we've got this board here, which is what feeds the ribbon cable to the top of the printer. So all of these lines, all the control lines coming off the board, they need to go to the top of the printer, are fed through those ribbon cables up there. Really, really nice detail with that. All right, I've searched all over Google and I cannot find any reference whatsoever to that chip number, FS31W01. And I do not think that is an accident, because I think that this is meant to be an unlisted hidden chip. I think it's a clone of a Trinamic TMC 2100. So if that's the case, these guys would be in big trouble if that ever came out, because the Trinamic is a patented thing. So basically, Trinamic can sue whoever uses this clone and get a whole lot of the profits that they're making from the clone, which probably isn't much considering the low cost on this printer and the great feature set that it has. Let's go over the reasons why I think this is a clone. First of all, let's look at the very obvious distinction here. We have 2 R100 resistors on both of these chips, And they're both connected to the same pins on the two chips. So let's count them. 1, 2, 3, fourth pin goes to that R100, and 1, 2, 3, fourth pin goes to that R100. Now at the bottom, it's a slightly different story. We have 1, 2, 3, fourth pin goes to that R100, and down here it's 1, 2, 3, 4. Fifth pin goes to that R100. So it seems to be different. But hey, take a look at the chips themselves. The Trinamic has 8 pins across the top, whereas the clone here has 9 pins across the top. But the clone also has 9 pins across the side, whereas the Trinamic has 10 pins across the side. So when you average out the number of pins, you could just, it's all the same. So we're talking 36 pins on both of these chips. So I think that they just took this pin right here from this spot where it is on the Trinamic. So there's the Trinamic spot, and I think they rotated that around right there. Yeah, so if that's the case, then this pin here belongs there instead, and we have 1, 2, 3, fourth pin over going to the R100 resistor. So same wiring on both stepper motor driver modules, and the similarities don't stop there. You look at these mid-sized components, these are like resistors and capacitors and stuff. There's 9 of them on both chips. Now, the Trinamic has a couple of these microscopic little deals, but those are, I think, for the fancy features that the Trinamic has that the clone does not have. So I think that basically this is just a dumbed down version of the Trinamic, running the same patented technology, but just running in spread cycle all the time. So an interesting thing that points to that is that these 2 pins here, which are soldered together, the ones I pointed out before, those map to CFG1 and CFG2 on the Trinamic thing here. So CFG1 and 2, those are the pins that you want to short to ground to determine the microstepping. This is most likely a clone. We'd expect nothing less from China. So, you know, if I was Trinamic, I'd be pretty pissed about this, and I would be suing Artillery, trying to get some of their profits, because this for sure is not open source. It is definitely patented, and rightfully so. These guys spent a ton of money to develop the most, trick, like amazing, silent, awesome stepper motor driver for 3D printers. They deserve their money. So that's the way that goes. On the other hand, as consumers, being able to get a cheap clone from China at like, what, 1/3 the price is pretty awesome. Still, Trinamic sticks are only like $10 a piece. Like, actually, I think you can get them for like $6 a piece. So, I mean, come on, you're saving like 18 bucks. But that's like a sushi lunch, so it's not that much, all things considered. And, we want to reward people who come up with awesome new technology, and that's why the patent system exists in the first place. Okay, let's do the numbers. For the uninitiated here, this scoring matrix is my attempt to be impartial and sort of judge a printer based on the sum of its parts. It's still got a degree of arbitrariness, like, how do you quantify a bed, on a score of 1 to 3? Plus the scoring, 1 to 3 itself is kind of an arbitrary decision. Maybe it should be 1 to 5. So whenever I go and get a new printer and I kind of go through the numbers, I try to go back in the to these lower scoring printers and also use the same new and improved judgment criteria that I'm applying to the new printer, and I try to give usually these get less of a score. I was more impressed with them at the time. But anyway, by the numbers, the Artillery Sidewinder is now the second highest scoring printer that I've ever seen, and it usurps the Two Trees Sapphire, which had that title just a couple weeks ago when I reviewed that one. So yeah, this the Sidewinder is very impressive. Solidly 4 points behind the Tevo Little Monster and 3 points ahead of the Two Trees Sapphire, so it's pretty solidly there holding that position. Now, I need to say that the Tevo Little Monster is not a great printer straight out of the box. So even though it gets this really high score, just because it has so many awesome features baked into it, it has a really crappy control board. So you're not going to get good prints straight out of the box. You're going to have to modify this with a Duet Wi-Fi in order to be happy with it. So quite a bit of work to do to the Tevo Little Monster to get it up to the print quality that the Artillery Sidewinder has straight out of the box, which is a really, strong suggestion that you should probably buy the Artillery Sidewinder if you just want the best printer out there. instead of the Teva Little Monster. But the value proposition isn't there. Of course, it's better than the Teva Little Monster at a 16.9. However, the value proposition for the Two Trees Sapphire is higher still. And the farther you go down the line here, you eventually get to this Creality Ender 3, which is going to produce prints that are every bit as good as this artillery Sidewinder. And at $175, it's a heck of a deal. So a 35.3 is the value proposition there. So the Ender 3 is about twice as good of a deal as the artillery. But of course, you're going to want to upgrade it to have all those features, which this one comes with. So it's a really impressive printer, and it's not that expensive. $450. That's still less expensive than the Prusa. So food for thought. Well, this is turning out to be a very long video, and I did not expect that when I opened up the box and saw this nearly complete printer. I thought this would just be a straightforward review and not much to say. But this platform turns out to be a fantastic illustration of many of the issues that you encounter in 3D printing. And that's not because there's really anything fundamentally wrong with this printer. It's a fantastic printer. It's just that it's this close, and so those details really come to the surface, and you can really talk about them quite easily. So I decided to take you guys along with me on the journey as I figured out the printer and as I was working with it to solve the problems. So that's why it turned out to be so long. But let's see if we can summarize everything that I covered in this video right here really quickly. Before I do that, big thank you to my Patreon supporters. These guys make this channel possible. Without their support, I wouldn't be here. So thank you so much. I really appreciate you guys. Okay, this printer is that close to being a viable alternative to a Prusa. What does that mean? It means that the quality is there, right? This is matching all of the polish that you see on a Prusa. And it's direct drive. So that's kind of the final thing that you can say about a Prusa compared to all these other Chinese printers, which are Bowden tube. Now, I don't like the inertial mass of a direct drive, but it doesn't really matter that much because in the x-axis, you can match the inertial mass of the bed. So in other words, this whole apparatus could weigh an equal amount to the bed and you wouldn't suffer print quality. So it's all about moving mass. So I don't like the i3 frame style overall, right? And it's such a dominant force in the market because of Prusa. That's just the way it is. And it's cheaper to make these frames, but that moving bed is kind of the Achilles heel of this design. So you have to print slowly. So as far as being a viable alternative to a Prusa, it's the same overall design. It's not a copy of a Prusa. Prusa is a copy of a Mendel, which was then reworked and blah, blah, blah. But so you can't say that this is copying. It's just a great alternative. Let's cover all the features that make it so great. First of all, the electronics fully enclosed in this metal case. Awesome. Touchscreen color interface, very user-friendly. That's better than the Prusa. You've got two options, an SD card and a USB drive. That's unheard of. I've never seen that before, although the SD card doesn't really work, so really it's just a thumb drive. It's your only option for getting files on there. Of course, it could be better. You could have wireless capability where you can wirelessly send files to the printer, so there is room for improvement. These ribbon cables, I've never seen this before. They're lightweight, so no inertial mass. They behave like your cable chains that you see on other 3D printers or CNC machines. So very clean wiring solution. I love the filament spool holder. Just so many great things about it. The redundant Z, how that whole thing works. The AC mains heated bed that gets up to temperature very quickly. The fantastic print surface, they just nailed it. So many things, just the best that I've seen coming from China. But of course, it has a few problems. I already talked about the SD card. Never was able to get that to work. And I did try it with an SD card from my Duet. So it's a brand new, uncorrupted, perfect SD card, and I couldn't get that to read either. So I'm convinced that is definitely broken. It's not my fault. But other than that, the other problems I was able to fix. And now this printer, as I've built it up to be, is definitely a replacement for a Prusa. So let's cover those issues. First of all, the skipping steps on that first layer. Joel Telling over on the 3D Printer Nerd had this same problem. His was the triangle thing that he talked about. I had that same issue too a few times. I just didn't show it on camera. But I was able to solve this because it's just a mismatch between Simplify 3D and this printer. Most of you guys are going to be printing using Kira, so you won't have this issue to begin with, but if you do use Simplify 3D, just delete those comments from the beginning of every G-code file and you won't have an issue. Now, it is to be said about this printer that it does get tripped up by those comments, but it's an easy fix. So I'm going to say that problem is solved. The second sort of very minor issue was cooling, and all of these printers come with a single source of cooling from one side of the fan. You'll see two fans to get you dual cooling, but why? Why are there no Chinese companies making a split cooling fan solution? I would say this split cooling solution here is probably better than the Prusa, which only gets you a hemisphere or a half circle of cooling. So the final thing, and this was the big one, is that Volcano hotend, which is no bueno. Like, this printer is a slow printing printer because that bed weighs a lot. And it's going to be moving back and forth, and if you move it too quickly, you get the ringing or ghosting on the side of your print as you get the microscopic vibrations that you can't see with your eyes, but they manifest on the print. So you have to print at a slow speed to avoid ghosting and ringing. And so what's the point in having a very high speed printing hotend? Right? So that's what the Volcano is designed for printers that can just fly through a print and you just can't melt filament fast enough. So it was a stupid design decision on the part of Artillery to put that on here. But I understand why they did it, right? The Volcano has a lot of buzz around it as being sort of an amazing hotend. It is E3D's latest and greatest hotend. Well, I guess the Super Volcano is their latest and greatest. So if you don't understand the nuances of why it's too much and it's not right for this printer, you could think of it as E3D's flagship greatest product and we better put that on our printer as well. But it's a mistake. We want to run a normal heat block on this printer, like all the other printers. There's a reason why we have normal heat breaks. They perform best with a 0.4 millimeter nozzle at normal printing speeds, like 40 to 60 millimeters per second. So they should not have put that Volcano hotend on this printer, and if they were going to put it on there, they should have made it easier to switch to a normal heater block and not have to go to the extreme lengths that I did. Now, I came up with two solutions. The one I ended up with, I don't like as much as my first solution, but my first solution had that major problem where it was only being held on by a single thread, and it's going to fail eventually. So if I could only get a throat or the heat break that's threaded all the way up, that would absolutely be the solution that I would be running with because the cooling, the J-head cooling was better on that solution. But this solution that I ended up with is pretty easy to do. Of course, it does involve grinding and cutting on metal, but this is aluminum. It's very soft and easy to do. So really, there's nothing special. You don't even need any 3D geometry from me. You just drill some holes and file away at that part, and then you can lower it. So really, I think that almost anybody should be able to accomplish the upgrade to a regular heater block on this printer and be getting prints that are every bit as good as you're going to find on a Prusa. But it's going to take a little bit of effort. Of course, it works really quite well straight out of the box. You just have a little bit of stringing that you have to deal with, and you might be able to engineer out the stringing through your slicer, doing some wipe moves. There's a number of videos. I've got one out there, and there's another number of other videos that teach you how to get rid of stringing. So you might be able to get that Volcano hotend to work for you. I just haven't had the best of luck with Volcano hotends as far as perfectly clean prints. So they are for printing quickly, not for printing nicely. Okay, what else is there to say? I should probably compare this machine to the comparable Creality printer, and that would be a CR10 variant. It's so confusing, right? They've got CR10 A, B, C, X, Super Pro. I mean, it's like, but anyway, there is a CR10 from Creality that's in this ballpark. Similar price point, touch screen, all that. And I think the biggest feature that differentiates the CR10 from this one is the bed leveling sensor. So they have I believe it's an inductive probe. Now, you can get the super duper high-end, massive Creality printer with a BL Touch, but I think the one that's comparable to this one has that inductive probe. And inductive probes are not good. I don't like them. I started off my channel and I used them on all of my printers, and I've since removed them from all of my printers. You gotta go with the BL Touch. The reason is that the inductive sensors are temperature sensitive. They change the readings that they give based on how hot or how cold they are. So Prusa has their Pinda probe with a temperature sensor embedded in the probe, and then they're compensating in firmware for the temperature difference to say, oh, well, we're this hot, so it's going to read this much different. So China needs to start doing that, and it's really easy to implement. I made it. I implemented that feature myself in one of my videos. You just drill a hole, stick a thermistor in there, and then go in the firmware, and it's easy. I don't know why they're not doing it, but really they shouldn't be using inductive probes. I don't like them. But really, they shouldn't be using inductive probes because inductive probes don't directly measure the print surface. They measure the substrate, the metal under the print surface. And in this case, there's a lot of glass, and I don't know that there's enough metal under that glass for an inductive probe to even read. I think they'd have to use a BL Touch on this printer, which is no tragedy. I love the BL Touch. So this printer does not have a BL Touch or mesh bed leveling, automatic bed leveling. And normally I'd be giving this printer a pretty big demerit for that fact. I definitely discounted the printer numerically in the scoring matrix for that fact, but there is a major sort of patch or a compensation that they've done to make up for the fact that they don't have bed leveling, and that is the redundant Z. So they've got two stepper motor drivers, one on each side, and then they've got that belt connecting the steppers across the top. So that Z axis is locked in place, it's not going anywhere. And I've found I adjusted the bed one time for this whole video. I have never touched the bed since then, and it's worked flawlessly for me the whole time. So bed leveling is not absolutely required. It isn't. However, it is nice to have in one situation, and that is if you're going to be changing up the filament that you print with all the time. So if you're going to print with ABS, for one print at 100 degrees Celsius for the bed temperature, and then PLA for your next print, and let's say you don't even want to heat the bed up. Like, you don't need to heat your bed up for printing PLA. So the bed will change its height based on how hot it is. So basically it expands and sort of warps and twists around a bit on you as it gets hot. Yeah, you're gonna need to do more bed leveling manually, but it's like an extra minute maybe of your time. So not a tragedy. It would be nice to have. It would truly be a Prusa alternative if they fixed the hotend issue and put bed leveling on it. I love this printer. I absolutely do recommend it for anybody who's looking to buy a printer under $500. Actually, under $450. I think you can get this thing for like $420. But follow the link in the description. That's the page that the manufacturer sells directly on. So that should be the lowest price that you can find this printer at. But I don't know. Shop around. Don't be a dumb shopper. It doesn't help me if you follow that link. Yeah. All right. Well, that's it for this video. It's been a long one, but I really appreciate your viewership. So thank you for watching. See you next time.